In this video, we will derive an expression for the circumferential strain and the longitudinal strain here. Okay. In the last video, we derived the expression for the circumferential stress and the longitudinal stress. Okay. So whatever we derived in the last video is it was circumferential stress equal to PD divided by 2T, right? Where P is the pressure of the fluid inside the cylinder, and D is the diameter of the inner diameter of the cylinder, and T is the thickness of the cylinder here. Okay, this is circumferential stress developed inside the cylinder here. It means, as we know that here, if you consider the cylinder, where the circumferential stress along the circumference, this is, if you consider a point, so this is along the circumference, this is circumferential stress, right? This is the expression. How about the longitudinal stress we derived here? Longitudinal stress is, that is PD divided by 4T. Only the difference is, say here 2 is there, here 4 is there. So how is the longitudinal stress? Along the length of the cylinder, this is acting here, that is sigma L. So we derived these two stresses here. Because of the internal pressure, these two types of the stresses develop inside the cylinder here, and that we derived. So if stresses are developed along the circumference and along the longitudinal, and if pressure is there inside the fluid of the fluid, then obviously there should be certain strain. Okay, due to these stresses there should be certain strain. What do you mean by strain here in the normal the static here? Strain is change in length divided by original length. Okay, if you consider along the length, how much change in length with respect to original length, because we have to design the how much increase in the length here. Okay, so that is we have to derive here. And along the diameter also it will be increases, that is the strain in along the diameter is, that is change in diameter divided by original diameter. With respect to original diameter, how much change in diameter, that is the strain in so two types of the strains developed. One is along the length of the strain, along the length there is a longitudinal strain, and along the diameter there is a diametrical strain here. Okay, these two strains we have to design. So from that, how much change from this equation, how much change in length, you can come to know that how much change in length due to the fluid pressure and due to these two types of the stresses. Okay, from diameter, how much change in diameter you can find out because of these two stresses and because of the internal fluid pressure. Okay, this is how. So in this topic the main focus is what is the strain in length along the length, and strain along with the diameter, and the change in diameter and the change in length. This is how we have to derive here. Okay, so now as we know that there is a diameter change, there is a length change, also there is a volume change. So volume change we will see later. First, how much change in diameter and how much change in length we will derive here. Okay, so as I know that is first come to the diametrical change. First one is diametrical change. So we know that the strain in diameter equal to change in diameter divided by original diameter, right? So from this equation we will find out what you mean by change in diameter. Therefore change in diameter equal to the strain in the diameter into the original diameter. This we will find out one. Now if you that is normally this is the circumferential, just I'll change the suffix here, that is circumferential, because along the circumference, here also I'll change it in circumferential strain. Circumferential strain, one more is longitudinal strain. Okay, so now the change in diameter is circumferential strain into diameter here. Okay, so now how we will derive this strain in circumferential strain? Okay, you have to apply the Hooke's law. Hooke's law, okay? Because normally the Hooke's law what it will say, suppose if any the body is subjected to, suppose the any three-dimensional body, it is subjected to the three types of stresses. For example, here one stress, and along with the x direction, and here along with the y direction, and here along with the z direction. If this body is subjected to the stresses in all three directions, different values, then if you want to calculate the only strain in the x direction, then only strain in x direction, how you will calculate here? That is, you know that the stress equal to stress E equal to stress by strain. As per the Hooke's law, E equal to stress by strain. This is general formula, right? Therefore strain equal to stress by E, right? Stress by E. This is general formula. Okay. Here, if you apply the strain in x direction, that is stress according to Hooke's law, stress in x direction divided by E. This is one, right? Stress in x direction divided by E. Minus, because it is also undergo the strain in y direction, also strain in z direction, because of these two stresses effects. Okay, we should not write only this much here. This is along the x, total strain in x direction is stress in x direction divided by E minus nu is Poisson's ratio, nu sigma y divided by E minus nu sigma z divided by E, right? This is normal equation. Just leave it this. Now I'm just explaining about the any body subjected to three types of the stresses in three directions. Okay. Similarly, how we'll write the strain in y direction? Strain in y direction is stress in y direction divided by E, right? Stress in y direction divided by E minus Poisson's ratio into stress in z direction divided by E minus the nu into stress in the x direction divided by E, right? This is how the derivation, in the previous video you can check it there, we derived this one. Similarly, strain in z direction, what is the, how we will write here? Stress in z direction divided by E minus nu into stress in x direction divided by E minus nu into stress in y direction divided by E. This is how the Hooke's law it will tells how much strain in total strain in x direction, total strain in y direction, and total strain in z direction. The same concept we have to apply now for the thin cylinders. For the thin cylinders, for cylinder it is having the two types of the stresses, right? So one is along the circumference, one is along the longitudinal, one is along the circumference. If we have two types of the stresses, yesterday we derived. This is PD by 2T and this is PD by 4T. We derived in the last video. Here I explained three stresses, but we consider now two types of the stresses. And same concept you have to apply here. Okay. Now come to the topic here. Come to the cylinder, our thin cylinder here. Apply the Hooke's law. Apply Hooke's law. Now the strain in the circumferential strain equal to, how we will write? Circumferential stress divided by E, that is E is the Young's modulus, minus nu is Poisson's ratio, which is one more type of the stress here, that is this is sigma L and this is sigma C. Now strain in circumference equal to stress in circumference divided by E minus nu into, what is that one more stress we have? The longitudinal stress divided by E here, right? This is how we have to write for the total circumferential strain in the thin cylinder. This will be equal to, now substitute. What do you mean by circumferential stress? In the last video we derived PD by 2T, right? Just I'll write here. We know that circumferential stress equal to PD by 2t, and longitudinal stress equal to PD by 4t, right? Now substitute these two value in this equation here. I'll substitute PD by 2t into E minus nu into PD by 4t into E, right? Now again the simplify. Just I'll take the outside, that is the strain circumferential strain equal to PD by 2t, 2te. Just take outside. How much it will remains? 1 minus, how much is there? The nu into 1 by 2. This is the circumferential strain. Okay. Now what is the equation for if you want to find out the change in diameter? What is the normal? One more equation is the normal equation is circumferential strain along the circumference is change in diameter divided by original diameter, right? This is also one more equation. So we can find out from this equation, we can find out the change in diameter, right? Therefore change in diameter in the thin cylinder equal to circumferential strain into original diameter. It's whatever d, capital D we took here, d here. So what is the circumferential strain here? We derived as per the Hooke's law, that is PD by 2t into E into 1 minus nu by 2 into D. This is the change in diameter of the thin cylinder. Okay, we should remember this is one equation while solving the problem, and this is one equation. Okay, PD by 2t, the normal PD by 2te into 1 minus nu by 2, circumferential strain. Now we will go for the longitudinal strain. This is also called as circumferential strain. Just remember, circumferential change, circumferential change strain here, or diametrical change. Now we will go for the longitudinal strain. Again apply the Hooke's law. Longitudinal strain along the length of the cylinder equal to, how we will write that in terms of stress and Young's modulus as per the Hooke's law, that is stress in the longitudinal stress divided by E. Okay, this is common, minus, also it is along the circumference, you have to minus nu into the circumferential stress divided by E here. Same like before, what just before I did there. Okay, this is how you have to apply. Now substitute the value of the longitudinal stress and the circumferential stress. Longitudinal stress is how much is there here? That is the PD by 4t. PD by 4t into E minus nu into PD by 2t into E here. Right? So now remove PD by 4te. That is, this will be equal to, remove the outside PD by 4te equal to into how much you will get? 1 minus nu into 2, that is into 2, that is 2 nu. This is the longitudinal strain. Now one more equation. What is that? Also we know that longitudinal strain equal to change in length along the length. Before it was diameter, circumference, now it is length. That is change in length divided by original length. From this equation we can find out the change in length, how much length change in the cylinder. Therefore change in length equal to the longitudinal strain into L. Substitute the longitudinal strain here. This will be equal to, that is change in length equal to longitudinal strain is how much is there? PD by 4TE into 1 minus 2 nu into how much? L into L. This is how the longitudinal strain and the circumferential strain. So now can we remember the longitudinal strain and longitudinal the circumferential strain? Just I'll for your remember, just I'll write here. First we derived circumferential strain, right? Circumferential strain equal to PD by 2TE, right? PD by 2TE into 1 minus nu by 2, right? This is circumferential strain. And longitudinal strain is PD by 4TE into 1 minus 2 nu, that is 1 minus 2 nu. This is the two equations you can easily remember, because PD by 2T normally comes to circumferential. Even stress, if you see that PD by 2T is the circumferential stress, PD by 4T is longitudinal stress. This we can easily remember. And here the E, as usual, the stress by strain, the strain is stress by E. Stress by, this is stress, this is E. This is 1 minus 2 nu, here 1 minus half of nu here. And related to this here, that is the circumferential strain is change in diameter divided by original diameter, because along with the diameter. From this you can find out the circumferential, the change in diameter. So related to this is the longitudinal strain is change in length divided by original length along the length. From this we can find out the change in length equal to this. These two will be helpful for while solving the problems. This equation and this equation, and in the last video we derived the stress, circumferential stress equal to PD by 2T, same here, PD by 2T, and longitudinal stress is PD by 4T. These two equations. Okay, this is how the we can find out the circumferential strain we find out and the longitudinal strain here. Okay.